Hello students, today we are going to see what is instantaneous center of rotation. So before talking about this topic, we need to have motivation that why do we need instantaneous center of rotation. So before we were dealing with only translational motion or rotational motion, and it was easy to find all these values like displacement, distance, acceleration, angular velocity and all. But if there is a scenario in which both of these motions happening, in that case it becomes complex to deal with such a situation. So we are going to see that what we can do in such type of motion. Such type of motion is called as journal plane motion. And here we are taking one example. We have a ladder here which is kept in such a way on a wall, and this wall is smooth. Because this wall is smooth, so definitely this ladder will slide on it, and at some instant the position of the ladder will be like this. Suppose if it was 5 meter and it was 4 meter, now it will be around 3 meter and it will be around 6 meter. So we can clearly see that it is varying, that distance is varying, so there is a translational motion, as well as this angle is varying. Here it was theta 1 and now it is something less than theta 1, suppose it is theta 2. So there is rotational motion also. Then how we will deal with such a situation? It becomes complex. So to deal with such a situation, we convert this journal plane motion to rotational motion, because it was easy for us when the motion is rotational. Then we can easily find these values phi, omega and alpha. So we are going to change this journal plane motion to rotational motion with the help of instantaneous center of rotation. And how we will find that? We will see that now. Suppose there is a center of rotation O and there is a radius of r, and this point A is moving in this direction, and suppose this OA is rotating with some angular velocity omega, and it is rotating around about this axis OA. So this translation velocity will be VA. We know that for a circular motion to happen, this velocity should be perpendicular. This is the same thing which we will do here to find the instantaneous center of rotation. Suppose our ladder was in this position. Now this point, suppose it was B and it was A. This B is moving downwards and this A is moving rightwards. So its velocity will be VB in this direction and its velocity will be VA in this direction. So we will take perpendicular from here and here, and where these 2 points are intersecting, this is our instantaneous center of rotation, because we will have one common instantaneous center of rotation for both of these points, because we are considering one scenario here. So this is called as the instantaneous center of rotation, and now we can deal with this situation as we were dealing with the rotational motion, and we can use all these laws which were in rotational motion. So this was all about the instantaneous center of rotation. Hope you have understood it well.